Pythagoras' theorem is one of the best topics that we do in mathematics because it leads into a lot more other topics like trigonometry, which I hope you will love. You'll find that it's very applicable to paving, plumbing, screen sizes, design, architecture, construction, navigation, surveying, right? It's just used in so many facets of life and in further study. So it's a great topic to get your hands into, and I think it's really nice. So what is Pythagoras' theorem? So what I'd like you to do is grab a ruler and a pencil, and the first thing that we're going to do is draw a right angle triangle, and one length has to be 3 centimeters, and then draw the other one that will make a right angle to be 4 centimeters, like the diagram is shown there. And then with your ruler, make sure that you measure the diagonal. And let's do a couple more. So now do another triangle that's 5 centimeters and 12 centimeters that make up the right angle. Again, measure the hypotenuse here, or the diagonal, sorry, giving a few things away. Do another triangle, 6 centimeters, 8 centimeters, measure your angle there and label it on your triangle, and be as accurate as you can, please. So feel free to stop the video while you do that, and once you're done, what we'd like you to do is fill out this table. So you can see for the first triangle we had lengths of 3 and 4. That was the A and the B, so we're calling these sides A and B. It doesn't matter if you call that B and that A, as long as we've got the two that make up the right angle. And then this one here, this diagonal, for the first triangle, I hope you realise that that was 5. And then over here we will fill out A squared. Now what is A? A was 3, so 3 squared becomes 9, and you'll pop that in this box here. And then what's B squared? B was 4, so 4 squared. Remember, squaring means 4 times 4. Pop that in here and keep filling it out. So again, pause the video while you complete that, and feel free to make one triangle of your own. Put those columns in there. And once you've done that, just make a little comment. Look at these last 2 columns and write down what you notice about it, please. So stop the video and get that. Right, so now you're back. Let's see, what did you notice? Bit of a thing Pythagoras used in Egypt ages ago, but the Greeks were the one to write it down. Anyway, what did you notice about those 2 columns? When we had our A and our B, hopefully what you discovered was that the length of this A squared plus the length of B squared was always equal to this C squared here. And this, you'll find, will work every time for right angle triangles. It's amazing. And that's why they use it in plumbing. They can check if they've got their pipes or their whatever at right angles just by checking and measuring that this little rule works. So I just want to show you an animated version of this. So we're seeing the areas here, right? 3 times 3, you've got an area of 9. So hopefully you've realised there that the areas of the A squared side plus the B squared will equal the C squared side. Freaky but true. There's another great demo here, but we're running out of time, so if you would just type into YouTube Pythagorean Theorem water demo, you'll be fascinated hopefully with what you see there. So let's just keep trucking. So to use Pythagoras' theorem, you need to know what the A and the B are, and I like to say they're the 2 lengths that make up your right angle. So if we look at this triangle here, it's this length and then this length that make up your right angle, okay? And so those are the ones that we call the A and the B. And if we look at our second triangle, you try and point out which ones you think are A and B. So find your right angle, and it's the 2 lengths that make up the A and the B. So we've got the A, and we've got the b. And of course, if you had them around the other way, the b on the left and the a up the top, that's fine. As long as, right, the diagonal, the hypotenuse, it's always has to be opposite the right angle, right, which is your little square there. So opposite that, that will be your C. And then let's find our other, I think opposite there, that's your C. And as long as you've got the C labelled correctly, you can't go wrong. So the other great thing about Pythag is that there's only ever going to be two types of questions, right? That's it, only two. There's going to be the type 1 where you're going to be asked to find the hypotenuse. So first things first, always, when you see that right angle, always write down the theorem. Once you've got your rule or your theorem, you then have to substitute your values in. Now remember what we said, what were A and B? They're the two lengths that make up your right angle. So in this triangle, it's clearly the 7 and the 12 that make up your right angle. So we substitute those in. And again, if you wrote 7 squared plus 12 squared, it's the same thing, all good. And your hypotenuse, we've called x here, so let's pop that in as well. There we go. And we're nearly done, right? Problem nearly over, because we don't want x squared, we just want x. Now, how do we get x by itself? We have to think, what is the opposite of squaring? The opposite of squaring is square rooting. And look for that little symbol on your calculator, and you just type in what you see there, and use your calculator. You get the square root of 193, and press the button on your calculator and you get 13.89 watching your decimals. And it's that simple. All I can really do is change the numbers. Instead of 12 and 7, it has to be, 13 and 4 or 22 and 18. That's all I can do to change those values or rotate the triangle. Please notice that this 13.89, the hypotenuse, it's always going to be the longest side. If the hypotenuse isn't the longest side, you better check because you've done something wrong somewhere. Alright, that's it for type 1. Let's have a look at type 2. And of course, that's where this time you have the hypotenuse, but you're missing one of the side lengths. So once again, always write your formula. And now we're going to substitute our information in. So again, what are A and B? They're the two lengths that make up your right angle. And in this case, they're 5 and x, or x and 5. So it's going to be x squared plus 5 squared equals 10 squared. Your job is to get the x squared by itself. So you need to get rid of this plus 5 squared. So you need to do the opposite. Can you tell me what the opposite of plus 5 squared is? That's right. The opposite of adding is subtracting. So you're going to do that to the other side. And now we're back to our problem where I just want x squared. I don't want x squared, I just want x. So the opposite of squaring, what we did last time, was square rooting. And we pop that into our calculator and we get our answer there. And that's basically it. Okay, now we'll do a couple from our textbook just to get you started. Okay, so let's see if we can apply what we've just learned to these two questions here. So once again, as soon as we see we've got a right angle and the question's asking us to find, this length here and this one here, right? We should straight away be going, right, let's look at our Pythagoras Theorem and write the theorem down. So it's a squared plus b squared equals c squared. So once again, what is our a and what is our b? Well, our a and b are the two lengths that make up the right angle, right? Here's the right angle here. And so it's going to be 4 and 10. Now, it doesn't matter if you write, well, let's stick with the pink. It doesn't matter if you write 4 squared plus 10 squared or 10 squared plus 4 squared, but make sure you write them one of the two choices, all right? 4 squared plus 10 squared equals, and our c squared, which is our hypotenuse, which is opposite our right angle there, that is going to be what we call x squared. Now, if you'd like, you can get your calculator out and we can go, what's 4 squared plus 10 squared and what have you, right? Or just do it in one swift maneuver. To get rid of this squared, the opposite of squaring is square rooting, which is 4 squared undo the 4 squared plus the 10 squared equals, that will be my x. And so we go to our calculator. Now mine's a little bit different to yours, but it will work in the same way. So to get my square root button is just above here. Look for that, right? So I go shift square root. On your scientific calculator, you've got a button that just looks exactly like that symbol, the square root with a little square underneath. Now I write 4 squared. You've got a squared button, so look for it. 10 squared equals, and your calculator will give you 10.77. So we look at that, look at the third decimal number. It's a 0, so we're going to keep this as 10.77. And remember, our check that we know that it's right is that the hypotenuse always has to be the longest side. So that looks like a reasonable answer. Right? Hopefully you're happy with that. Now let's have a look at this question here. Once again, it's a right angle here, and it's asking us to find an unknown length. So again, we write our formula. And now what we're going to do is substitute our information in. So you have to find out what are the two lengths, so A and B, what are the two lengths that make up your right angle. So here's my right angle, which means it's that length. Oops, and that length. Bit of a wobbly line I did there. So in this case, my two lengths that make up the right angle aren't the two numbers that I've been given. Don't say it's just, oh yeah, 8.7 squared and 38.6. It's the 8.7 and the x. So I'm going to write, that means it's x squared plus 8.7 squared equals 38.6 squared. Right, now we don't want this whole thing, the x squared plus the 8.7 squared. So I want to get rid of this plus 8.7. And hopefully you remembered in the example that we did before, to get rid of the plus 8.7, we are going to subtract. So it's going to be x squared, and we're going to subtract that from the other side. So minus 8.7 squared. And I don't want the x squared, I just want x. So we are going to square root 38.6 squared minus 8.7 squared, and our calculator is going to do all of the work. We will know that we're going to have a good answer if this answer is less than 38.6, because remember, the hypotenuse is always the longest side. So let's have a look at our calculator. I'll have to move it over to the other side. Okay, so once again, we're just going to type this in. So we're going to go square root and 38.6 squared minus, okay, that's where you have to be careful. If you accidentally put the plus, right, you will end up with a number bigger than 38.6, and that's where you will realize, oops, I've made that mistake, because we know the hypotenuse, the length that's opposite your right angle, that has to be the biggest number possible, the longest side. So this side x is going to be 37.6. Now I want two decimals, so I look at the 60, but I must look at the third number. So because that's 5 or more, I round up 60, I round it up by 1 to 61. So this becomes 37.61 centimeters. Now please make sure that you've got an example or a copy of each one of these examples in your book. So this one you can call type 1 or example 1, and this one we've got type 2. Make sure that's nice and clear, because you can then keep referring to these examples when you do different questions. Hopefully that helps you with Pythag.